Hey, welcome to ITS128, Chapter 11. Before I start, any questions from the previous chapters? Oh, okay. All right, so we'll get into modules. Okay, so let's look at this animation first. Okay, so a module is where you can store Python code in separate files. So you can see here we have two Python scripts. Okay. Okay, so what we're showing here is instead of if you have common functions like FCT and SQ, instead of storing it all in one Python script, you can create a module just to define those functions, and they can be used in other Python scripts by importing them as modules. Let's move on to a challenge if there is. Here we go. Okay. So learning modules, it's I think it's better, it's more of a thing that you practice and you'll see. So we'll just go over a few things here. Okay, so in this case, uh we're importing arithmetic, and we'll show you the code for arithmetic, right? There's a function called calculate number, and all it does is return that number minus 5. Okay, and then here we have the same function calculate defined in here. And now we're going to print calculate, and we're going to print arithmetic.calculate. So in this case, we're adding 5. So okay, so if we're going to print calculate 3, then this should output 8, we would think, right? And now when we call arithmetic.calculate, it's going to subtract 5. Oops. So it should be a minus 2. So let's check that. And that is correct. So you can see that when you do calculate, you're taking the function that's in your current Python script. When you qualify it with arithmetic.calculate, then it's going by what's imported. Yeah, you can use the same name. So it's differentiated by how you're qualifying it here, right? So you can imagine if you have a large program that maybe many people are working on, you can have a lot of name collisions. And there's very specific rules of how basically in any programming language, how it resolves those collisions, whether it'll generate an error or what the order is. So that's something to always watch out for. Okay, so now we'll try a coding challenge. Okay, so we have string traveler name and integer num luggages are read from input. Okay, so we're reading these two. Module airline kiosk defines check-in, and module airline luggage defines check bags. Import modules, airline kiosk, and airline luggage. Okay, so let's look at airline kiosks. So it just has the check-in implemented. Airline luggage has check bags implemented. So all we need to do here is import those modules. So it's very simple. So let's just go and copy what we got here. Cut and paste that. No. Here. Let's check that. Okay, so that's it. So uh, basically here, as long as you don't make a typo, it'll import properly and the rest of the code will run. So we're good there. Okay. So now, okay, so let's look at finding modules. Okay, importing a module begins a search to find the corresponding file on the computer's file system. Okay. So this is a key thing when you're using modules. If your program is simple and you have everything in one directory, then it's fairly certain. But when you have a complex program, you might want to put things into multiple subdirectories and such. So here it says the interpreter first checks for a matching built-in module. Okay. So built-in modules are base functionality that comes in Python already. So you don't have to worry about handling them as separate files. So they're built in. Examples of built-in modules include sys, time, and math. Okay, so you'll see that when you code. So now, if no matching built-in modules is found, then the interpreter searches for the necessary modules in sys.path, a built-in Python variable locating in the sys module that has a list of directories containing modules. Okay, and here, this is a key point. A programmer must be careful not to give a name to a module that is already used by a built-in module. Right? So this is an example of if you have a name collision. So if you made a module called math, uh, it won't result in an error. So the way the Python interpreter works, it has a precedence order. So as soon as it finds that module in a built-in, it doesn't continue on. So your math module will never get loaded in that case. Okay, the sys.path variable initially contains the following directories. So directory of the executing script. So that's the simple case where your script and your modules are all in one directory. A list of directories specified by the environment variable Python path. And the directory where Python is installed, right? So you have several options of how you want to arrange your modules. So here, yeah, it says simple programs module might be placed in the same directory. Larger projects may contain tens or hundreds of modules, right? And especially third-party modules. So you might not be writing all the code. You might be incorporating third-party modules that's, part of a package that you download. So that's when you can set a Python path variable. So this is an example for Windows type. Okay, so let's move on. So just like with built-in modules, when you have a path, the path is searched in order. So if you have Python path, dir1, and then other directory. So the same thing will happen. If you have two modules of the same name, it'll load the first one that it finds in the path. So in dir1, if you have, let's say, a module called classroom, and in other directory, you also have the module called classroom. Because the path is set up this way, the one in dir1 will get loaded. Yeah. If you change your Python path to swap these two, then the other one will get added, right? So naming if you have a large program, naming convention is very important. Okay. To importing names. Okay, so a programmer can specify names to import from a module by using the from keyword in an import statement. So we can do from module name, import name1, name2. Okay. Let's look at this here. So it says a normal import statement such as import HTTP server adds the new module into the global namespace, after which a programmer can access names through attribute references HTTP server dot address. Okay. In contrast, using from adds only the specified names. A name such as that, statement such as that, copies only the address variables from HTTPS server into the importing module's namespace. Okay, so let's see what that looks like. Okay, so we're importing my mod. So in a normal import, imports it into the global namespace. And in the my mod namespace, you have the value x and the function calc. So this shows you here that, so in the running script, assigning y puts that in the global namespace, z is in the global namespace. My mod is in the global namespace dot calc. So from there, it goes to the my mod namespace, finds calc, and executes calc. Okay. Okay, so in this case, now uh, we're saying import calc from my mod. So what that does is it puts calc directly into the global namespace so that you don't have to qualify the my mod dot namespace, and you can just execute calc. So doing this will make it like the function calc is in your own script. So this is an example here. So if you did a normal import, yeah, you always have to specify the module name, right? If you do a from, and then you import the, so this only works for the specific things that you're going to import into the global namespace. Then you can just do address, right? So like in this example, we did from my mod import calc. So X never got put into the global namespace because we're only importing calc. So this is a bigger example here where we're importing MD5 and SHA-1 from hashlib. So basically you can call those functions directly. Uh, let's see. This example, improve the hashing example from above by adding a new algorithm. Import SHA-224 from hashlib. Extend the user interface to allow that function to be called. So next up, fix me add check for SHA-224. Wanted to do that. We just do another else if. See, see the code for the hash lib here. Hash lib, maybe hash lib is a built-in. But in any case, uh, so this is an example. So if I didn't do this, let's try run it without doing that. Uh, I'm still I'm still doing a check here to allow the user to do it, but I'm failing my import. So this should not run properly. Oh, here. Yeah, this is the here. Oh, wait. Yeah, so this is the input screen. So if I do SHA-1, that should still be fine. If I do 224, it's going to run through this code and try to call this function. So it should still detect it and call it, but because it's not an imported name, it's going to fail, right? So now if we do SHA-224, now it runs. Okay. Now all names can from a module can be imported directly using the star. And a common error is to import star syntax in modules and scripts, which make identification of dependencies and the origin of variables difficult for a reader of the code to understand, right? So when you're importing from a module and you import star, know, a lot of times when you're using the module, you probably did not write the module, and you're certainly not going to look at every single function in the module. So if you did a import star, there may be other things in hashlib uh, that you may not use. Uh, that in itself is not a problem, but if you had a function in your code that had the same name, then it'd be very confusing to troubleshoot, right? The wrong one could get called. So, you know, so if you want to just make sure everything in hashlib is covered, you can do star. Right? When you run something like this, it'll run properly, won't fail, right? But you might be getting things you don't expect. So you have to choose the right times to do an import star. Uh, Hashlib could just be every single one of these types, and maybe you do want them all without having to type out every single one. So in that case, import star is okay to use. But if you had a bigger library that had a lot of other things that you may not want to use, then it would be a problem, right? At the same time, you don't have to do you don't have to do that. You can just import it the first normal way without importing the names into the global and in your code. So I would suggest anywhere you can, you should not use the import name unless you have a really good reason for it. You should do the classic import. And when you do that, you're going to have to qualify your methods with the module. But what this does is when you look in this code, you can clearly see that, oh, I'm calling hashlib module functions, right? Whereas the other way, you can't tell exactly which ones you're calling uh, because you're just saying MD5. You'd have to look up at the import to see what you're importing, right? The When you use a Python IDE, the Python IDE will definitely help you. It'll tell you what your call stack is and everything. But just from a code readability standpoint, this makes more sense. And doing the import namespace is a shortcut that you may not want to use unless you understand exactly what you're trying to do. So if you run this, this should still run. Okay. Okay, so there's no challenge for this one here. Let's go to executing modules as scripts. Okay, an import statement executes the code contained within the imported module. Thus, any statements in a global scope of a module, such as printing or getting user input, will be executed when that module is imported. So execution of those statements may be an unintended side effect of the import. So a programmer wants to treat a Python file as both a script executed by the interpreter and as an importable module. Okay. When used as an importable module, the file should not produce side effects when imported. Okay, so let's look at this example. Web search py contains functions for performing searches that scrape results from a fictional web search engine. Okay, executing the file as a script produces the following output. So let's see. So in this module, uh, web search, so these functions that get defined here, these don't get executed because these are definitions, right? But now you're doing an assignment here right? And then you're doing another assignment here. So you're invoking input, and then you're invoking your search function, and then you're doing a print, right? So it's gonna produce some output. Okay. So if another script imports web search to use a search function, the statements at the bottom of websearch.py will also execute, right? So this is doing an import of web search, right? So let's see here. So the domain freq py file below tracks the frequency of specific domains and search results. However, importing web search py causes a search and listing of each site to unintentionally occur because that search is called at the global scope of web search.py. So as soon as this import is done, it's going to produce the same kind of output like you have here before it does its own output. Right? So now we see that a file can better support execution as both a script and an importable module by utilizing the special name. So this is what you can do. So if you're doing if name equals main, that indicates that this is being executed as a script versus being imported. Okay, so here's a change here. So these definitions are fine, but these are executions. So we want to wrap this in a if name equals main. So what that does is if you execute web search py by itself, then it'll act like a normal Python script and it'll execute that. But if you're doing an import, this condition will not match, so it won't run any of these. And then the rest of the script that imported it can call functions within that module. Okay. Okay, let's look at reloading modules. So sometimes a Python program imports a module, but then the source of the imported module needs to be changed. Since modules are executed only once when imported, changing the module source does not affect the running Python instance. Right? So instead of restarting the entire Python program, the reload function can be used to reload and re-execute the changed module. So the reload function is located in a built-in import lib standard module. Okay, so let's look at this. We're doing an import here. Okay, so this is a module that we're going to use. So if we want to use reload, we're going to import it from import lib. So we're going to say from import lib, import reload. So from before, remember if you do a from import, then reload gets into the global namespace. So then you don't have to say import lib.reload. So that's how they're using it here. And in this case, we're importing send Gmail module to execute this. So we're going to re-execute this every time we do a reload send Gmail. Okay. Okay. I don't think there's going to be much challenges for this chapter. Okay, for packages, so instead of importing a single module at a time, an entire directory of modules can be imported all at once. So a package is a directory that when imported gives access to all of the modules stored in the directory. Large projects are often organized using packages to group related modules, right? So this is key. So and this is especially important when you're getting third-party modules. When you extend, you're getting libraries from third parties, they're usually going to be large packages, so it'll be arranged as packages. Okay, so in this case, we're doing 2 imports to get music and effects. So here we have import sound.music sound.effects. So that's part of the naming now. So it'll be sound, then music, sound, then effects, right? Or you can import game.sound, then you get all of that, everything under sound, and game.graphics, and then you'll get all of these modules. So it's flexible how you want to do it. You basically whatever whatever level your import goes to, it takes everything underneath that. So when you do sound music, that's at the lowest level. There's nothing else to import. But when you say game.sound, it'll import everything under sound in the sound directory. Okay. Okay, so there's some conventions to follow to properly identify a package. So to indicate that a directory is a package, directory must include init py. Okay. So that's another way to arrange a larger program. So this would be more for practice. So no challenge activity here. Now we're already at the last one, standard library. Okay. Yeah. So by default, Python includes a collection of modules that can be imported into new programs. So the Python standard library includes various utilities and tools, right? So example, the math module, right? The SQL module, you know. So basically, uh, anytime you learn a language, the constructs of the language and how it works, it's it's very that's a very small part of the language. To do anything useful with the language, you need all these library functions, right? So this is where, you know, so by default, Python will provide most of the common things that every Python program will use. And then on top of that, you would add third-party libraries to do other things. So if you were using a different type of database, like if you're using an Oracle database, there's a Python Oracle module or package that you would download and add to your Python installation so that you can use it in your program. So for that to install something like that, you would look back at you know all the importing, setting the Python path and all of that. Okay. So all of the Python standard libraries, is well documented. Uh, so these are very common functions. Date time. Date time is one of the most common things in any programming language, and it's not inherently built into any language. It's usually a library uh, associated with that language. Okay. And then right here, there's a documentation that documents all of the standard libraries, right? So 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 this is readily available on the internet. Also, if you're using an IDE, a lot of times the IDE will help you identify any library that you're using. It'll identify with the built-in documentation for that. Okay, so since we have time, let's look at this optional lab. Okay, so given integer input seed, how many max num, generate a list of how many unique random numbers, random integers from 0 to max num inclusive. That means including 0 and the max num. Complete function, unique random ints, generate a list of how many random integers from 0 to max num. When a random number exists in the list, a new random number must be generated. Use a global variable, retries to count, and return the list. Okay. Then complete main, initialize the random module, and then call unique random ints to get a list of random integers. Output the list of random integers. And value of retries. Okay. So not sure if I got all that on the first pass. So let's see what an example is. So if the input is 257, let's see. Okay, so main is going to define this function. Okay, so the inputs is the seed. Second input is how many. Third input is max num. 7, okay. Max num, okay. So initialize with the seed. All unique random ints to get a list of random integers. Output the list of random integers. and the value of retries. Okay. So we're gonna seed it and we're gonna do 5. So 0, 1, 2, 4, 5. Why is there no 3? Max num. Oh, max num is 5. Okay, so we're gonna generate 5 random numbers, which is this 5 here. Turn the list, generate a list of, okay. Yeah, this is a little confusing, but uh, we're gonna try to, we're gonna generate random numbers between 0 and 7, including 0 and 7. We're gonna make 5 of them, and then we're gonna print how many times, we want 5 unique ones, and we're gonna print how many retries we had from the random number generator. So uh, when you call the random number generator, you can get the same number more than once. So in this case, it's saying we have to keep track of what's already in the list, and if we see the same number again from the random generator, we increment the retries. Okay. Okay, so let's try this. So this is more of a just a coding exercise. All right, so the simple part is just making the call. So complete main, initialize with a seed value, and then call the random ints to get, okay, so we're gonna call random ints with the how many and max num, right? Now we need to do the seeding for that values according to the output format shown below. Okay. Print here. First, we need to do the seeding. So let's look at the Python library for random. Okay. Random. Okay. So random seed. Initialize a random number generator. A is omitted or none. Okay. And version 2, version 1. Okay. So the version, I believe, is it optional? Yes, it is optional because it's gonna assign 2. Both of these are optional, but we're gonna run it with a 2. Okay. Or we're gonna run it with the value of seed here. So random dot seed. So you can see the ID will help you. Execute it with seed. Here, turn a list of from 0 to max num using seed to initialize the random module. Functions for integers. So rand range. What's that? Turn. Yeah, so rand in. Return a random integer n such that a is less than or equal to n less than or equal to b. Alias for rand range a, b plus 1. Okay, so that makes sense. So in this case, this would be less than equal, so that means it's inclusive. So it should be rand int. So you're right. So we'll just put this as a placeholder, right? So it's going to be 0 to max num. Okay. So that'll generate a random. Okay. And now we're gonna have to put this in a loop. We're gonna have to put this in a loop to generate a list of how many, right? Just that. So, and we're not gonna just run it how many times, because each time we get a new random, we have to check if it's included in the list. And then so we'll have to do a while loop of some sort. And we'll have to keep track of the retries. So the retries has to be a global, because this function will return a list, but we also have to print the retries here. So, okay. Of the number of times an existing number is generated. Okay, so yeah, yeah, this one will get kind of involved, but uh, so I'm just showing you steps of how you would start constructing the program. So instead of just writing it all at once, you can brainstorm. You can see, okay, this is gonna be a while. So maybe you put that as a comment. We know we're gonna call random like that. We know this is all fine here. Well, but we need to make a print, right? So let's just print brand list. So before we format everything, let's just do simple prints just to make sure we got it. Retries. Okay. Now let's see. I'm going to open another Zybooks tab. So let's go review lists in Zybooks. So how do we make a list? Look at some code, right? Okay, so that's one way to make a list. Then let's look at, we can also look here. So there's plain lists. Not here, lists. So these are, oh, these are the functions for the list. So let's look back here. So we want to be able to generate a list, right? Here. We got a page not found. Okay, here. List. Looking at list methods. Oh, here we go. We can do extend, append, insert, right? Okay, so let's do and list equals, right? The append here. Oh, list dot append. Yeah. So is that right? My list dot append. Yeah. I wasn't sure why the IDE didn't pick up append. Okay. Okay, so just for fun, let's just do this 3 times like that before we make a loop. Right? So we're gonna keep getting a random value and we're gonna keep appending it. And then we're gonna return rand list. Okay, so let's try running this. The same values. Okay, so what it did was it got 3 random numbers, put it into the list. So it's printing into the list, and then it's printing retries. So we never did anything with retries. So that's fine. So the steps you can take is, okay, now we kind of got the steps we got. Now you need to go put it into a while loop properly. You can see that when we're doing the random numbers, we got 1 twice. So this is an example. So the algorithm should be where you grab a random, add it to your list, right? So the first time it'll just be 1. And then the second time around, it's random, so you're not going to get the same. But let's say we get a 1 again. Then we're going to increment retries and get another random. So we're not going to insert 1. We're going to get another random and insert it again, or check it again. So the next time, let's say we get the 5, so then we would just have 1 and 5, and the retries would be 1 in that case, right? And we're gonna keep doing it until the list size is 5, right? So now let's try that. So while so what we should do is we should make the rand list outside of the while, and let's look. How do we get the size of the list? Okay, it's not list.count. Let's look at this, iterating over a list iteration. It's a different type. It's the list basic. Okay, so I'm not seeing how to get the size of a list, so we'll just do a web search. Python list get size. Okay, it's saying you can use a len function as a built-in. Okay, so let's try that. Okay, so while len rand list less than 5, right? Or how many? You're right. We're gonna get a random. Then come back here. There was a list method we can check. So it was list count. Count the number of times value X is in the list, right? So that we could use that. So rand list dot count R. Say if rand list dot count dot R is 0, so it doesn't exist in the list, then rand list dot append, right? It's dot append R. Colon. Yeah. Then we'll do else. We're gonna do retries. Increment retries. So now let's see. So while it's less than that, it's gonna keep adding. It's gonna keep getting a new rand list. Okay, let's just try run it, see what happens. Okay, So we got some errors. Unbound local error. Local variable retries referenced before assignments. Okay, so why is that? Retries. Okay, so this time it went through it. Um, try print every time we do a retry. Okay, so it did do a retry, but it never did this. So the reason is this retries is being treated as a local variable. So it's not making it to the global, right? So the Python global variable in function. Ah, so we have to declare the global, right? Let's do that. Retries. Okay, now let's try run it. Okay, did one retry, and it's showing one here. Okay,
Try it.
what's that?
Uh, line 14.
Mm-hmm.
Sure, it's not decided.
Setting to 0. Uh, let's see. I think yeah, so it's global. So in this case, uh, we we might want to do it here because every time you run this, you want to know how many retries happen for that run, right? So, oops, retries not defined. Okay. Oh, there's probably a more proper way to define the retries, but I can do that there, which is redundant. Now we got it. So let's try some different values. So let's try 2, 7, 20. Right? It still ended up doing a retry, but now we have 7 elements, right? So you can see how it's run. So I'm not going to bother doing the print format. That's always tedious, but if we wanted to do the submit for grading and get it, then we'd have to print it out just like this, right? But we get the idea. Okay. Any other questions?